Good morning, class. So, welcome sa ating General Chemistry class, and this morning we are going to talk about calculations in chemical equilibrium. Now, before we proceed with calculations, let us first review the basic concepts of chemical equilibrium. Okay, so we have two types of chemical reactions or chemical equations. We have the irreversible reaction and the reversible reaction. So in an irreversible reaction, as you can see, it has a single arrow pointing on one direction. Okay? So yan yung clue kung para malaman natin kung ang isang reaction ay irreversible. Okay? Single arrow lang siya going from reactants to the products. In an irreversible reaction, before the reaction, you only have the reactant. And then during the reaction, the reactants are being converted into the product. Okay? Now, if you have an exact proportion of the reactants, okay, yung stoichiometric amounts ng ating reactants, tamang-tama lang talaga sila, walang sobra, walang kulang, then all of the reactants will be converted into the product. Or kung hindi siya ganun ka-proportion, meron tayong limiting or excess reagent, all of the limiting reagents will be consumed, okay, to produce the product. Now, pagdating naman sa reversible reaction, malalaman natin kung reversible ang reaction kung yung arrow sign natin ay dalawa. Okay? Baliktaran yung turo. From the reactants going to the product, and then from the product going to the reactant. Okay? So, in a reversible reaction, before the reaction, you only have the reactants. Now, during the reaction, the reactants are being converted into the product. But take note, in a reversible reaction, yung product ay nako-convert din pabalik into the reactants. Now, initially, okay, simula ng reaction natin, mas mataas yung rate of reaction from reactant going to the product. Okay? Mas mabilis yung formation ng reactant natin to product. Okay? From reactant to product. Kumpara dun sa product going to the reactant. Kaya mapapansin ninyo, mas malaki yung arrow nung sa reactant to product kumpara sa product to reactant. So, mas mabilis yung rate ng formation ng product kumpara sa formation ng reactant. Now, as the reaction proceeds, after the reaction, okay, magbabalanse na yung rate of reaction na yan. Okay? So, yung rate ng formation ng product at saka yung rate ng formation ng reactant ay equal na or the same. We call that as dynamic equilibrium. Now, by the way, it doesn't necessarily mean na porket nagbalanse na yung rate of reaction tumigil na yung reaction. Hindi ganoon ha. Patuloy pa rin yung chemical reaction. Yun nga lang, yung rate ng forward reaction at saka yung rate ng backward reaction ay magkapareho na. Kaya parang feeling mo hindi na nangyayari yung chemical reaction pero tuloy-tuloy pa rin yun. Okay? Yun lang kasi yung rate ng forward at saka rate ng backward ay magkapareho na. Kaya hindi na natin masyadong napapansin. Okay? Na nagkakaroon pa rin pala ng chemical reaction. So, chemical equilibrium occurs when a reaction and its reverse reaction proceed at the same rate. So, yun yung chemical equilibrium. So, as a system approaches equilibrium, both the forward and the reverse reactions are occurring. Sabay pa rin silang mangyayari, yung forward reaction at saka yung backward reaction. At equilibrium, the forward and the reverse reactions are proceeding at the same rate. Okay? Now, dahil pareho na yung forward at saka yung backward reaction, okay, once equilibrium is achieved, the amount of each reactant and product remains constant. Okay, wala na tayo makikita observable changes sa sa concentration ng reactant at saka ng product once na na-achieve mo na yung equilibrium. Okay? So again, tatandaan, a system at equilibrium, their rates are equal and their concentrations are constant. Okay? Yung bilis ng forward at saka ng backward reaction ay magkapareho na. Kaya yung concentration ngayon ng reactants at saka ng product at equilibrium ay constant o hindi na nagbabago. In a system at equilibrium, both the forward and reverse reactions are running simultaneously. Tatandaan nyo yan, ha? So, patuloy pa rin na nagaganap yung chemical reaction at equilibrium. So, we write the chemical equation with a double arrow just like this one. Okay, now the equilibrium constant. So, what do you mean by equilibrium constant? This is a number equal to the ratio of the equilibrium concentrations of the product to the equilibrium concentrations of the reactants, each raised to the power of its stoichiometric coefficients. So, like for example, in this equation, we have N2O4 turns to 2 moles of NO2. So, reversible reaction yan. Yung forward reaction natin ay yung N2O4 becomes 2 moles of NO2. Yung reverse reaction naman ay mula product going to the reactant. So, 2NO2 becomes N2O4. So, dalawang sabay na reaction na nangyayari. Okay, at the same time. Now, to generalize, the reaction is like this. Okay? Yung reactants natin ay yung A and B. Yung products natin ay C and D. Yung mga small letters, beside those capital letters, are their stoichiometric coefficients. Okay? So, pag sinulat natin yung equilibrium constant expression, we write it as this. Okay? Bracket, again, means concentration. So, ibig sabihin yan, pag binasa natin, concentration of C raised to the power of C times the concentration of D raised to the power of D all over concentration of A raised to the power of A times concentration of B raised to the power of B. Okay, that is equivalent to Kc or the equilibrium constant. Okay, meron din tayong ginagamit pa to express the equilibrium constant expression, yun ay yung Kp naman. If we are using pressure as an alternative for concentration. Kasi actually may calculation pa na pinapakita dyan pero hindi na natin, hindi ko na ipapakita sa inyo para hindi tayo mahirapan pare-pareho. So, for Kp, ang equilibrium constant expression natin dyan ay partial pressure of C raised to the power of C times partial pressure of D raised to the power of D all over partial pressure of A raised to the power of A and partial pressure of B raised to the power of B. So that's how you write the equilibrium constant expression for pressure. If pressure ang pinag-uusapan natin, Kp ang tawag natin. Okay, so let's have some practice problems. You may pause this video, tapos gawin ninyo yung mga problems na yan, and then play nyo ulit para malaman yung sagot dito sa mga problems na ito. Okay, so let's do this. So again, to write the equilibrium constant expression for the following equations, so we have Kc, capital letter K yan ha. So, over. Tanda natin product over reactant. So, ang product natin ay ito at ito. Now, again, based on the previous video that you watched, so hindi natin sinasama sa equilibrium constant expression ang liquid, pati ang solid dito sa number 2. Okay? Why? Kasi, again, minimeasure natin o in-express natin ang equilibrium constant expression in concentration or in partial pressures. So, wala namang pressure, kumbaga observable talaga na pressure, ang liquid at saka ang solid, at hindi rin tayo pwede mag-express ng concentration kapag liquid at solid ang pinag-uusapan. Sa chemical equations, malaman natin na solution, in solution ang isang reagent, reactant or product, kapag ang nakasulat ay AQ or aqueous. Okay? Hindi G, hindi S, hindi L. AQ ang nakaloob sa parenthesis dito. Okay? AQ yun. Okay. So again, let's write the equilibrium constant expression for the following. So, product muna tayo. So, we have NH3, ilagay natin sa bracket, and then raised by the power of the stoichiometric coefficient, which is 2. So, hindi natin ito isusulat kasi nga in liquid siya. Sa reactant naman, sa denominator natin siya ilalagay, parehong gas, so pareho natin siya ilalagay. So, NO2 bracket raised to the power of 2 kasi, ayan o, 2 yung stoichiometric coefficients natin, so squared, times H2 raised to the 7th power dahil sa coefficient natin na 7. Now, since mga gases yan, hindi yan in aqueous solution, pwede rin natin siyang express in Kp. Okay? Pero may ano tayo, may ibang solution kasi kapag pag sinusulat natin siya in Kp, at i-consider din natin yung temperature kapag Kp ang pinag-uusapan. So for now, Kc muna tayo. Okay. So number 2, we have Kc is equal to, product muna tayo. So nag-iisa na lang kasi hindi pwede itong solid. So Kc is equal to SO2 squared all over concentration of O2 cube. So, ganun lang kasimple ang pagsulat ng equilibrium constant expression ng mga equations. Titingnan nyo lang kung nasaan yung mga gases or mga aqueous solutions. Ilalagay yung concentration sa sa product. Pag product sa taas, reactant sa baba, raised by their stoichiometric coefficients. So, what are we going to learn in this lesson? You are going to learn how to calculate equilibrium constant, calculate the concentration of reactants and products at equilibrium, and calculate pressure of reactants and products at equilibrium. So, first sample problem muna tayo. How do you calculate for the equilibrium constant? Okay? So, the following equilibrium process has been studied at 230 degrees Celsius. So, ito yung ating chemical equation. In one experiment, the concentration of the reacting species at equilibrium are found to be 0.0542 molar for NO. Concentration of O2 is 0.127 molar and concentration of NO2 is 15.5 molar. Calculate the equilibrium constant or Kc of the reaction at this temperature. So, yung temperature, ignore nyo muna yan. Sa Kp siya mahalaga. Pag Kc pinag-uusapan, medyo ignore muna natin ang temperature. So, the first step is you write the equilibrium constant expression. So, Kc is equal to, okay, so wala tayong may exempt dyan dahil lahat naman sila ay gas. So, we have NO2 squared dahil sa stoichiometric coefficient niya na yan. And then, NO squared times O2. Okay? Now, to solve for Kc, all you have to do in this type of problem, all you have to do is plug in all of the given. Okay? So, solve na natin. Plug in na natin. So, ang ating NO2 ay 15.5 molar. Yung unit ay hindi na natin lalagay. Bakit? Kasi, by the way, yung equilibrium constant natin or Kc ay walang unit. Okay? Hindi natin siya ginagamitan ng unit. So, 15.5 squared. Tapos, yung reactant natin ay 0. Sorry. Bayan natin muna ito. 6 na siya. So, 0.0542 squared times, ang O2 natin ay 0.127. Okay? So what is 15.5 squared? So 15.5 squared is 240.25 over, square natin ito, then multiply kagad natin dyan sa katabi. So 0.0542 squared times times 0.127. So the answer is 3.73 times 10 to the negative 4th power. So 240.25 divided by the denominator, we will get, okay, so sulit natin dito sa baba. Okay, our KC now is 6.44 times 10 to the negative, to the 5th power. Okay, hindi siya negative. So that is our KC in this problem. Ganun lang kasimple. Paplugin mo lang lahat ng data dun sa ating equilibrium constant expression, then you solve for the KC. Okay, next. How do we calculate for the concentration of reactants and products at equilibrium? Now, let's say you are given a certain amount of reactants before a reaction. Okay? Paghahaluin mo yung mga reactants, and then gusto mong malaman ano yung magiging concentration ng reactants and products after at equilibrium. Okay? So, a mixture of 0.50 molar H2 and 0.50 molar of I2 formed HI, or hydrogen iodide, as shown in the equation. What will be the concentration of H2, I2, and HI at equilibrium if the equilibrium constant is Kc, or Kc is 54.3 at 430 degrees Celsius. Again, pag Kc, hindi natin kinoconcern yung sarili natin sa temperature. Hayaan muna natin yan. Okay? So, meron tayong given na Kc, tapos yung initial amount ng reactants natin. Gusto natin malaman yung magiging concentration ngayon ng reactants and products at equilibrium. Now, in the previous video, okay, napanood na ninyo kung na meron tayong ginagamit na special table to compute for the amounts of the reactants and products at equilibrium. So, hindi tayo gumagamit dito nung ginagamit natin dati sa stoichiometry. Medyo komplikado ng konti ito dito sa chemical equilibrium. Okay? So, we will be using the ICE table, or ICE, Initial, Change, and Equilibrium table. So, again, first step is to write the equilibrium constant expression. So, our Kc is equal to, okay, ang product natin ay Hi squared over concentration of H2 times the concentration of I2. So, this is our equilibrium constant expression. Okay. So, next is we write the ICE table. So, before we do that, sulat muna natin yung i-rewrite natin yung chemical equation. So, we have H2 plus I2, okay, will form 2 moles of HI, and this reaction is a reversible reaction. Okay, what is the initial concentration of the reactants or products? Pwedeng given din yung product, okay, pwedeng reactants lang. So, in this case, given yung concentration ng reactants. So, 0.50 for H2 and 0.50 for I2. So, magre-react pa lang sila. So, ibig sabihin, wala pa tayong HI. Okay? Now, kapag sila ay nag-react, ano ang mangyayari? Siyempre, mababawasan yung concentration ng H2, mababawasan din yung concentration ng I2. Hindi sila completely mako-consume, mababawasan lang sila. Diba? And then, magkakaroon tayo ng certain amount of HI. with a coefficient of 2. So, dahil hindi natin alam kung ilan yung may babawas sa concentration ng H2 at saka ng I2, we represent that as X. Pero dahil sabi nga natin, mababawasan, then minus. Okay? Same with this one, minus X. Okay? Mababawasan sila ng a value of X. Hindi lang natin alam kung ano yan. At, base sa chemical equation natin, okay, madadagdagan naman yung product natin ng dalawang amount ng X. Plus yan. Okay? So now, at equilibrium, ano na mangyayari? So, yung 0.50 ay mababawasan ng X. Ang I2 natin na 0.50 rin ay mababawasan ng X. Tapos, ang product natin ay magiging 2X na. Okay? So, to solve for this one, i-plug in na natin itong mga values na ito dito sa ating Kc or equilibrium constant expression. So, ang Kc natin nga pala given na, so it's 54.3 is equal to, ang product natin ay 2x. Pero base sa ating Kc, it's squared. So, square natin siya. Over, okay, ang reactant natin ay, by the way, pareho silang 0.50 minus x. So, pwede natin i-simplify na lang siya as 0.50 minus x. Kung hindi sila magkapareho, then, i-retain natin, susulat natin sila ng as is. Okay, squared. So, since pareho namang squared yung numerator and denominator, to solve for x, we can just get the square root of both sides of the equation. Okay? So, the square root of 54.3 is 7.37 is equal to, magiging 2x na lang siya over 0.50 minus x. We cross-multiply our denominator to the other side of the equation. So, we will get 3.685 minus 7.37x is equal to 2x. Transpose natin to sa kabilang side ng equation. So, we will get 3.685 is equal to 2x plus 7.37x. 3.685 is equal to 9.37x. Divide both sides of the equation by 9.37. Okay, para maiwan na lang si x. 9.37. So, cancel, x na lang ang naiwan. So, x now is equal to 0.39. Tapos na ba tayo dyan? Hindi pa. Si x pa lang ang nasolve natin. So, to get the concentration of H2, I2, and HI at equilibrium, okay, ang H2 natin, initially we have 0.50. So, minus natin ng x natin, which is 0.39. So, the answer here is 0.11 molar at equilibrium na sila. So, ganun din sa sa I2. Since pareho lang naman sila ng concentration ng H2. So, 0.50 minus 0.39 is equal to 0.11 molar din. Now, for HI, okay? So, ang formula natin is 2x. Ayan, no? So, therefore, we have 2 times 0.39. So, ang concentration ng HI natin, in this case, is 0.78 molar. Okay? Yan na yung kanilang magiging concentration at equilibrium. Okay? So, next problem tayo. Now, in this case, pressure naman yung isosolve natin. So, the equilibrium constant Kp for the decomposition of phosphorus pentachloride to phosphorus trichloride and molecular chlorine is this. Is found to be 1.05 at 250 degrees Celsius. If the equilibrium partial pressures for PCl5 and PCl3 are 0.875 atm and 0.463 atm respectively, what is the equilibrium partial pressure of Cl2 at 250 degrees Celsius? Ito medyo basic pa. Okay? Hindi pa natin gagamitin ng temperature dito kasi given naman yung mga values na kailangan natin to compute for Kp. Okay, so yung equilibrium constant expression natin for Kp, kapareho rin lang naman sa sa Kc. Okay? So Kp is equal to yung products natin. Okay, PCl3. Wait. Dahil ito nga pala ay pressure, okay? Hindi tayo magba-bracket. Partial pressure ang gagamitin natin na symbol. Partial pressure of PCl3, okay, times the partial pressure of Cl2. Wala tayong mga power dito kasi wala namang stoichiometric coefficient dyan. 1 lang yan. Okay, all over the partial pressure of PCl5. Okay, so in this problem, you're just going to plug in all of the data that we have from the problem. So meron tayong Kp. Kp is 1.05 is equal to ang ating PCl3 ay 0.463 times the partial pressure of Cl2 over the partial pressure of PCl5, which is 0.875. Okay, transpose natin yan dyan, or we multiply both side by 0.875 para makancel ito, malipat doon sa kabila. So, we will get 0.9188 is equal to 0.463 times PCl2. Okay? So, transpose natin ito by dividing both sides of the equation by 0.463. Cancel. So, yung partial pressure na lang ng Cl2 ang may iwan dyan. So, the partial pressure of Cl2 now is 1.98 atmosphere. So, ganoon lang kasimple itong problem na ito. Kasi nag-plug in ka lang ng data dun sa equilibrium constant expression natin. Okay, let's have another problem. Now, in this case, we have Kc as a given. Okay? So, ang hinihingi sa atin ay Kp. Kung Kc ang given at Kp ang hinahanap, we will be using this formula. Hindi ko na i-discuss kung paano nakuha itong formula na to, but just to give you a clue, okay, about this one, ginamit dito yung ideal gas equation. Kaya nga meron tayong 0.0821, which is, kung naalala ninyo, this is the R, or ideal gas constant. Okay? And then, yung delta N here, okay, ano ibig sabihin yan? Delta N is the mole of the product minus mole of the reactant. Okay? Tapos yung temperature, this should be expressed at Kelvin temperature. Okay? Kelvin. Ayan. So, tandaan nyo lang equation na yan kapag Kc ang given. Okay. So, we have the problem again. Methanol is manufactured industrially by this reaction. The equilibrium constant or Kc for the pressure is 10.5 at 220 degrees Celsius. What is the value of Kp at this temperature? So, let's solve for this one. So, isulat uli natin yung ating, in this case, hindi na pala natin kailangan isulat yung equilibrium constant expression kasi meron na tayong Kc eh. Okay, given na yung mga variables, so hindi natin kailangan isulat ang equilibrium constant expression. So, mag-plug in na lang tayo ng data. Pero let's solve for this muna at saka ito. Okay? So, delta N is the mole of the product minus the mole of the reactant. Ang mole ng product natin ay 1. Okay, 1 lang kasi yan. Sa reactant naman, we have 1 and 2. So, total of 3. So, 1 minus 3. So, ang ating delta N is negative 2. Okay? Now, for the temperature, ang temperature kasi natin ay 220 degrees Celsius. So, 220 plus 273. Tulad nung dati, hindi natin susulat yung 0.15 para hindi na tayo masyadong mapahirapan pa. So, this is 493 Kelvin. Okay, so now let's solve for Kp. Kp is equal to, ang Kc natin ay 10.5 times 0.0821 times the temperature. Ang temperature natin ay 493 and then raised to negative 2. Okay, so 10.5 times, solve muna natin yung nasa loob ng bracket. So 0.0821 times 493, that is equivalent to, i-retain muna natin marami-raming decimal places. So, 40.4753 raised to negative 2. So, erase na natin siya sa negative 2. You will get 10.5 times 6.1041 hanggang i-round off na lang natin siya tapos 2 decimal places mamaya. Pero mag-extend tayo hanggang dito. Times 10 to the negative 4th power. So, multiply that, we will get Kp is equal to, okay, so times 10.5, you will get 6.41. Okay? 6.41 times 10 to the negative 3. That will be the value of your Kp. Okay? Using this equation. Kapag ang given ay Kc at ang hinahanap ay Kp. So, that's it for today, class. I hope you learned something. And after this, siguro later this afternoon, pag hindi ako busy, so pasensya na, medyo busy talaga ako ngayon. Sobra-sobra. So, magpo-post ako ng practice homework na gagawin ninyo sa Classcraft. At sa Classcraft, by the way, ay pwede na kayong mag-earn ng GP o gold points para ma-update na ninyo yung mga avatars ninyo. Okay? So, that's it again for today, class. Thank you. Goodbye.